I will confirm we are live on major platforms. Confirmed, we're live on X, we're live on LinkedIn. One more. We're live on Twitch. Okay, we are live everywhere. So let's go ahead and begin. So hello, everyone. Welcome to our Friday live stream on Golem, using Golem, which is an agent first, a runtime that combines durable execution with features that are geared specifically for building agentic applications. And this Friday, we're going to take a look at how we can get a great library known as Effect AI to work on Golem. And we're going to build some sort of agent example that uses model inference directly using Effect AI. In previous weeks, we've done this with TanStack AI and then Vercel's AI SDK. And I think we had a great experience with both of those. But obviously, if you're one of the many TypeScript developers out there who is building in the Effect ecosystem, then those libraries are not nearly as attractive as Effect AI. And what Effect AI brings, of course, is very, very tight integration into the overall Effect ecosystem. You have layers, for example, to construct provider-specific implementations that can be plugged into Effect AI for purposes of doing model inference. You get integration with Effect Schema for describing input and output types for any tools you happen to be using. And just overall, everything feels very seamless and native if you happen to be an Effect AI user. Now, I have actually played around with Effect AI on top of Golem prior to doing this live stream. So I have some sense of how this is going to go. And honestly, I think that we, meaning the Golem ecosystem, can do a much better job providing a really first-class integration with Effect. And I say that because right now, our TypeScript support for Golem expects you to, for the public API of your agent, it expects you to return promises. And as an Effect user, what you really want to be able to do is return effects from all of your public API methods inside your agent. And so that's not currently supported because our TypeScript support is just generic. It doesn't depend on any TypeScript library or ecosystem. So you can use it with whatever, but it does entail a certain amount of boilerplate, which to me does not feel right. In addition, I think an Effect-specific integration could probably do a great job integrating with Effect Schema and could potentially even handle things like config and whatnot using layers. So I have a bunch of ideas for how Golem could bring a native integration between Golem and the Effect ecosystem. We don't have that today, but the TypeScript support is really solid. So we're going to base our work off of that. So to get started, let me go ahead and pull open a terminal window and share that with folks. And Daniel, maybe you can confirm you can see that.
Not yet. Now something. Yeah, we can see that. It's a
Right.
little bit small, but I can read it. Now it's better.
All right. So this is my old directory in which I did all these experiments, I'm going to take the very dangerous step of blowing this all away, I think. And we'll just start from scratch with one minor caveat that I'll mention later. All right, so we're building Effect AI, some sort of Effect AI based application on top of Golem, which implies we're going to use Golem to actually build. We'll use Golem to get our initial template, and we'll test that. We'll make sure everything's working. And then, and only then, will we consider adding Effect AI on top and trying to make some sort of hello world problem. Once that's working, then I think, Daniel, we can come up with a new example of building an agent that is not related to what we've done in previous weeks, because we got that feedback on Discord. People are tired of seeing us build to-do agents that can talk to each other. I will never tire of that. I think it's super cool, a really great example of Golem's agent-to-agent communication. But I understand those folks who are attending these sessions weekly probably want to see something new. So let's think up an example, something new to give them. That could be fun and also maybe somewhat realistic or useful. All right, so Golem new is how we create a new template. This one is going to be, I'll call it Golem Effect AI. And we're going to do TypeScript. I'll use the default counter template. And the package name will be Effect AI : Golem. Or maybe it should be, I guess that's fine. We only want one component in this application. I'll just go ahead and choose to create it. Okay, so we have Golem Effect AI. And let's see here. I'm just thinking how I want to structure this for my existing workflow. And I think what I might do is just copy all this stuff into a new directory. I just want to set up here another directory. Let's see here. Okay, yes. So I'm going to go into main here. Actually, I'm just going to open this stuff. And what I will do is I like to use, I have a tool set that's assuming work trees. I'm trying to use that pervasively. So I just want to make sure I'm able to take advantage of that and not have to recreate anything from scratch for purposes of this live stream. So what I'm just going to do is copy all the stuff that Golem added into the main work tree here. And once I see that's working, yes, so it's all copied in here. I don't need that old Golem directory. I'll just go ahead and blow that away. And I'm going to open up the whole thing here. Hopefully you can see this. You should see, Daniel, you should see open code.
Yeah. Yeah,
Please
it's very visible.
Okay.
Good font size and everything.
Just peek around and see what we got for free out of this. It'll be a bit tight here with the font size being this big. Okay, so here's what we got out of this Golem template. We've got the counter agent, which has a constructor, and then this single method over here called increment. Let's just go ahead and build that. I'm going to go into components TS into this directory that you see the root directory here for this component. And I'm going to do a Golem build. Let's see what happens.
Actually, you don't have to go to the component directory. It's better if you just stay at the root. But Golem
Okay,
commands work.
I'll go back.
But
to
if
the
you do
root.
an npm install here, that's sometimes not
All
working
right.
as expected. So it's better to be at the root directory.
Fantastic. I'll go back to the root after I verify this succeeds.
If there is only one component in your application, it doesn't matter for Golem CLI itself.
Okay, so Golem build, verify, yes, it's done. And then Golem deploy, I think I'm probably going to get an error here. Yes, okay, so that's just because the Golem server is not running. So what I'm going to do is in a separate window that's not shared, I'm going to do a Golem server run. Just get that running so I can keep an eye on it. And now I'll try Golem deploy again. I can see plan changes and all that great stuff. Just going to go ahead and Golem deploy. Okay. So now I'll start the REPL and see what we see. All right, I see my counter agent. Here's my counter agent source code here. And it has a single method, which is increment. So I'm going to create a counter agent by using the API, TypeScript API for this. I'll just have pets counter here. It's the name of my counter. This is actually the constructor parameter to the agent that you see here. I'll create that in the REPL, and I will do an increment. See what happens. Okay, get back 1, get back 2, get back 3, etc. So Golem is a durable agent runtime, which means all these agents exist durably. And they might be loaded into memory and consuming CPU when they're busy, but when they're not busy, when they're suspended, when they're waiting, when you're not using them, then those agents are stored in cold storage. And so we never have to worry about persisting the state of our agents. Golem takes care of that automatically. Every agent has durable state. This agent will exist forever until we delete it. And Golem agents also have transactional code execution, which just means that basically if there's any failure event that occurs while an agent is doing active work, Golem detects that failure, resumes the agent, or restores the agent, working from the state immediately prior to the failure event, such as, maybe there's a network error, maybe there's a CPU failure, maybe Kubernetes kills some pod or a server is restarted, whatever. Golem detects that and resumes the agent from where it left off with its state intact, and making sure that previous actions that the agent took, previous sort of side effects code that was executing, is not performed twice. It's only performed once. So all of this stuff is baked into the Golem runtime. It's not something we have to program to. There's no SDK that we have to use in order to get these features. We just get them automatically everywhere over our entire TypeScript application. So to demonstrate that, I'm just going to exit this REPL. And I'll actually kill the server, just so you know I'm not cheating. Server's dead. Let me, yeah, so I'm trying to start the REPL. The server's dead, so that's not going to work. I will start up the Golem server again. And then I'm going to start the REPL. And I'm going to grab this agent, the same agent again, call increment again. And the number is 4. So what we've done is we've survived a crash event. Our agent is still there. It's still operating as usual. It still has all the same state inside its brain that it did before, and we don't have to worry about any persistence. From this agent's perspective, that state is just a number here, but it doesn't matter where the state is stored. It could be stored inside here or outside there. It doesn't matter. All state is captured and is restored perfectly to the moment before the failure event. So we just don't even have to think about it. All right, so this is working, but it obviously, well, actually, let me take a step back and talk about one more thing. I said this agent exists, And it actually has an agent identity. So every agent has an identity. And me as a developer on Golem, I get to choose what that identity is by two pieces of information. Number one, by the name of my agent. So this becomes a part of the agent identity, which means different classes in TypeScript have totally different agent identities. Even if everything else were the same, if I have two classes with two different names, then those are sort of two different families of identities. And then the other piece of information that forms the remaining part of agent identity is the constructor parameters. So here I have a single constructor parameter called name, which is meant to be the name of this counter agent. And that forms the remaining part of the agent identity. So the full agent identity is actually the sort of composition of the agent type here. This would be referred to as the agent type in Golem speak, as well as constructor parameter values. And what that lets me do is it lets me talk to specific agents, right? Every agent has a unique stable identity. And so I can arrange my distributed system in such a fashion that different agents can talk to each other, knowing who they're talking to. So you can choose these names. You can have as many constructor parameters as you want. They can have any sort of structure that you want. So this is really no restriction on you. It just allows you for agent-to-agent communication purposes to make sure you know who you're talking to and coordinate work between different agents. Very handy feature that saves a lot of work, but does require getting used to that. Okay, so I think we're ready here to do a minimal hello world example involving Effect AI. And what I will do in order to make that possible and relatively straightforward is add this existing agents.md here into this effect directory or into the effect Golem directory in order to provide key details of how Effect AI works to open code. So I'm using open code for purposes of the demo today. I'll use open code to make modifications to this TypeScript project. And just to make sure that we're able to be as productive and as efficient as possible, I've already pre-created a little agents.md that teaches my open code coding agent everything it needs to know in order to interact with Effect AI and to build like hello world examples using Effect AI. So what I'm going to do here is just a very basic test to make sure that we have enough context inside this open code session to be productive. I'm going to ask open code to build and deploy the Effect AI Golem script component using Golem, and then test that it works. We'll just see what happens here. Note, whenever you create a project from a Golem template, like you saw me do at the beginning, you actually get a top-level agents.md that teaches your coding agent how to work with Golem. So in theory, open code already knows how to work with Golem. It knows how to build stuff, how to deploy it, etc. Let's just go ahead, and it's encountering some difficulties. That's fine. We'll just let it figure stuff out and learn from that. Okay, it's already gotten to deploying it. I can see all of these backend commands in my server window, which you don't have access to. And it's also doing something here, which is interesting. It is calling our API on this agent. So you may notice here that our agent decorator has a mount parameter. And this is an optional feature of Golem. So every agent you create has a public API. Well, public in the sense that Golem knows about it. It's not necessarily public to the world, but Golem knows about it. And this public API includes the constructor, obviously, which is what we saw in the REPL here. But it also includes all of the public methods that are on this class. So in this case, it includes increment. And that is great for using Golem tooling like the REPL and whatnot. But in some cases, you may want like a REST API, an HTTP API on top of your Golem API. And so we have actually a very new feature called code first endpoints, where you can basically mount an agent at a given URL. And then now all of the methods of this agent that you choose to export are going to be accessed at this URL prefix. So here we've got /counter /name. This is actually coming from the constructor parameter. So basically our little REST API here for interacting with counter agents looks like this, counter / and then the agent name there, the counter agent name, which comes from here. And then we have a single endpoint, which is /increment, which would be appended here. So it'd be /counter /name /increment. And this is going to be a post. So this endpoint is a post. So you would post, and there's nothing to post. So the body would be empty. And that's coming from the fact that there are no parameters here. And then it's going to return a number as output. So that's what you see here. When OpenCode is testing this agent, it does a curl with /counters and then /test counter, which is the agent name, test counter, and then /increment, and it gets 4. So what I should be able to do here is let test counter equal counter agent dot get test counter. Oh, actually, that is my test counter, right? That's already agent dot increment 5, right? So in this little test, which actually came from the HTTP API, which Golem added as a result of this decorator, and of course this one determining the route path to these agents, it went from 4 to 5. So all of that appears to be working correctly. It looks like, as far as I can tell, we are ready to begin the process of refactoring this simple counter agent to be an agent that uses Effect AI and has a sort of hello world demonstration of how Effect AI lets you talk to model providers. So I actually have in my system environment variable, I have an API key for Open AI. And what I want in this hello world example is to use that Open AI API key to construct a layer, an Effect AI layer that is going to end up constructing in a provider, a model provider, that I can then use to do some basic chat so that I can call out to the model and do model inference on. So what I'm going to ask my open code coding agent to do is basically add that. Using Effect AI, rewrite the counter agent to be a chat agent, which does a minimal hello world demonstration of using Effect AI on Golem. All right, so I'm going to kick this off. And while I do, I'm actually going to take a second here and let my dogs out. 1 second, I will be right back. All right, I'm back. I will have to let those dogs in. Got a new puppy. And that one needs to take a lot of, oh, okay. So did not make as much progress as I wanted because I have to specify, I forgot to specify the LLM provider. I want to use OpenAI because I've already got that set up in the environment. Let me just quickly talk about how this works. So this YAML file here in Golem is a manifest file, a Golem manifest file for this TypeScript component. And you can basically define environment variables here inside the manifest file that will end up being packaged up. When you do a build, and actually when you do a deploy, all these environment variables will be packaged up and sent off to Golem server. In this case, Golem server is running locally. And so it's going to have that information available and accessible. In TypeScript's case, it's going to have it available in process env. So I'll show you that. Actually, it's right here. You can see it right here. Process env is going to contain that environment variable. Now, this YAML file is using this syntax here, which actually gets an environment variable from my own system environment variable. So ultimately, this OpenAI API key is coming from my system environment variables, and then it's being embedded inside the bundle that gets built every time I do the build and deploy command. Okay, so let me go ahead and take a look and see what's up here. Looking at main TS, I can see that my coding agent has done a few different things. First off, it's refactored my increment method to be a query method. And this query method takes a message, do a post to query there, takes a message, and then calls a language model.generate text, feeding a history. I'll talk about that in a second. And using this language model layer, which has been configured to be the OpenAI language model, the GPT-4o. Okay, so this bit of code is constructing a layer that provides a OpenAI model, and it requires actually a fetch client. Well, actually, we're using the fetch client. You could use something else if you wanted, but we're using fetch for Golem. And then this API key here is coming from process env open API key. So all this looks correct. Now let's talk about history. So the history of messages that we're going to use every time we interact with the LLM is coming from this private field here called history. And it's using this effect AI type called message encoded. And what's happening here is initially the history inside the constructor is initialized to be a singleton array that contains a single entry here, where we're giving the AI a system prompt to say you are a helpful assistant named whatever. And then we're telling the assistant its name, which is coming from this constructor parameter. And then every time you call query, we actually push the user message onto this history array, and we feed the entire history array inside this generate text method so that the LLM has access to all prior conversation history. And then after the LLM gives us a response, we go ahead and push that onto the array containing the full text of the response as text. So this is going to allow our agent to be stateful. And it's going to be stateful in a way that, because of the guarantees Golem provides us with, is also automatically durable. So let's just demonstrate this. Let me enter the REPL again. And I can see I have a chat agent here with a single name. So I'm going to do agent equals chat agent dot get Alice. And I'm going to say agent dot query who are you? I'm going to ask the agent who it is. And the agent says, I'm Alice. And how does it know that? Well, it knows it because that was actually part of the very first system prompt we used up here, which is, you are a helpful assistant named Alice. Now, let me just demonstrate its statefulness here. What was the last question I asked you? And we get back, the last question you asked was, who are you? Okay, so it's stateful. We haven't demonstrated, however, that it is durable. Now, let me just kill the server. Server's dead. I restarted the server. Starting up the REPL. I'll ask the agent again, what was the last question I asked you? And of course, it's going to be, what was the last question I asked you? Because I asked that question 2 times in a row. So here we have the basics working. We did not have to take care to persist that conversation history because everything in Golem, no matter where it is, whether it's in our primary agent or in a global variable or some third-party library, everything that is inside this running application is automatically durable. We don't have to do anything to get that. It just comes for free because we're using Golem as our runtime for deploying this application. So now we're at the point where we have a hello world example that demonstrates basic model interaction using Effect AI and has, I think, reasonably best practice around constructing these layers. I think you might be tempted if you're programming in Effect to make top level layers, but I think I'm not 100% sure, but correct me if I'm wrong, Daniel, that probably would not work in our case, because if we were to access process.env at the top level, then we might encounter some sort of problem with it not being initialized. Is that right?
I think it's always working actually, but
so maybe we can pull this out to the top layer if we want. We could probably.
I think so.
Yeah. All right. So that's good to know. All right. So what now? Well, talking to the model is one thing. We want our model to do things. So what I'm going to ask open code to do is just add a very simple example of a tool, a simple tool inside this agent. It doesn't have to do anything too fancy. So we can actually see the Effect AI library successfully using our tools, feeding our tools to the model, allowing the model to choose which tool it wants to run, and then having Effect AI actually run that tool, and all that sort of data interchange being handled properly. And when we get to that point, we basically have our hello world with tools. And that's a good point where we can talk about, okay, we're done with a toy example. What do we want to actually build today in this session? Let me have and what I'm going to do here is I'm going to ask open code to add this tool as a method on my class. Why? Because as you can see, the Golem REPL knows about all of the methods on my class. And so if I add a tool as a method on my class, then I'm going to be able to interact with it directly and also test it, right? But also interact with it directly from the Golem REPL and from other Golem tools, and even expose it as a public method if I want, using an HTTP API just by adding a new endpoint there. And I want all of these properties. They're very valuable to me. So I'm going to ask it to make sure that it does that as a tool, or sorry, as a public method. I will also give this a tool access to any state inside this particular agent, which can be useful. I'll have a lot of these libraries have this distinction between the definition of a tool and the implementation. I want the definition of the tool to occur at the top level because it's never going to change. And then I want the implementation to be defined in here. And the implementation is, of course, going to capture the state of this particular chat agent, this. So I need to do that in line here. So let's give it that task and see what it comes up with. And then after we get this working, we'll talk about how we want to, what sort of real or more realistic example we want to build for today. Okay, so here we have, not surprisingly, a roll die tool that is defined using this make function inside the tool object. So we have tool make. Here's the name of the tool, the description. Here's a description of the parameters using effect schema. And we describe the success and failure schemas. This one cannot fail. So we use schema never.
I think your coding agent was watching the previous episodes.
Was it? Oh,
I think your agent was watching the previous episode, so
it seems
knows
like
what kind of tools you want to do.
It actually, it's probably because the very first time I did this with TanStack AI, I just asked it to add any sort of tool, and it just settled on rolling dice. So probably in its training data, that's a very common example of a trivial hello world tool add. Okay, so what's going on here? We've got some problems. The LLM called the tool but returned empty text. That's because the model's final turn was the tool result only. Okay, so what basically happened is the model we're using here, which is ChatGPT 4.0, decided to make the last thing it did call the tool. So it called the tool, but we didn't get any useful output out of that. So what OpenCode is doing is just making sure if we don't get any response, we use the last tool result as our response. And in order to do that, it looks like it's having to, let's see, response. Okay, so tool results, it's looking in the tool results of the response that we get back from generate text. And it is stringifying the tool response result. And then it's pushing, is it pushing? Yes, it's pushing that text, the stringified JSON, onto the history array. So basically in the result or in the outcome, that the only thing the model does, or the very last thing that the model does, is call a tool. Then we're going to grab the result of that tool, turn it into a string, and append that to the message history, which makes sense to me. Okay, so in theory, this is working. We have this single tool and wrapper, and you can see that it added a method to our chat agent class. So in theory, we should be able to access this inside here. You can see our chat agent gained a method, and it's roll die. So let me use that directly. I'm going to get Alice agent again, and I'm going to call agent.roll die. See what happens. All right, I have to provide a argument, and this type signature is done by magic. So the error messages and types are not very good in this current version of Golem, but it's gotten better in the master. Just am using a week-old version of Golem. Okay, so I have a single parameter here, which is just sides. We'll use a six-sided die. And I get back 1, get back 2, get back 6. Okay, looks good to me. So now we have a hello world tool. And we have to decide from here, what are we going to do? So let me just temporarily stop sharing my screen and we can hash this out. So we want to build an agent today using Effect AI running on top of Golem. And we don't want it to be a to-do agent like last week and the week before. So Daniel, any ideas for something we could plausibly do in the next, let's call it 45 minutes?
Well, I don't have any specific ideas, but I think what would be nice to spawn a number of agents from one agent to demonstrate that they can you can parallelize work like that, and that nicely matches probably effects, combinators, and stuff. But what to parallelize, I have no idea.
Yes. What to parallelize? Yeah. So one potentially thing we could do, or just comes to mind when you say parallelize, is obviously research can sometimes be an important part of building agents. And when you're researching, you have to look at a lot of different things and pull back that information and maybe summarize it. So that could potentially be interesting. Now, just
Yeah, I had a blog post about writing something like that in a Rust agent a few months ago. That was basically every agent represented I think a web page, and then it was doing some kind of analysis on that page and spawning further analysis if needed, something like that. But I'm not sure that's the best example for this demo. I might take a little bit more time. Although with a coding agent, it might just make it in a few minutes. I'm not sure. Not sure.
yes. One question is, using a fetch, are we going to be able to retrieve the content of a web page, or are we going to run into any sort of issues? I guess that's going to be server specific, whether or not we don't impose. I don't think we impose any sort of restrictions on fetch.
No, it should work like fetch, and no restrictions from Golem side.
Okay, so we'll be able to access the content of any domain. We don't need any cores. We don't need it to support cross-origin cores or anything like that, presumably. So we can use fetch to pull back the content of a page, assuming that the target website is going to allow us. See, when we do fetch, I just wonder what's going to happen in terms of like user agent and whatnot. But, we can try it. Let's go ahead and...
Yeah, I think you can just set all those things in fetch's options parameter. I don't know the syntax, but it should be all there.
Sure.
And then we could use Effect AI to actually do something with the fetch data. I don't know.
Yes, makes sense. Okay, so let's
summarize it or whatever.
Yeah, for sure. Let's maybe, as a first step, just add a method that maybe it should be called fetch, that just grabs a static page and adds it to a sort of documents field inside the agent. And the idea here being, okay, we want to fetch this URL and this URL and this URL. So we'll add a public method. We'll just test that it works in a simple case. It's going to grab the content of that URL, and then it will add it to a private documents field that's stored in the agent, so we can fetch as much as we want. And then maybe all of that becomes part of the context, or maybe not. Maybe we summarize it. We'll just start with the simple fetch then. And another method to chat agent to fetch a given provided URL and add this to the tools.
Do you want to share your screen again?
Oh, well, right.
We cannot see it.
I forgot I stopped sharing my screen, didn't I? Is it back?
Yes.
So add this to the tool we supplied to the model as well. And then I don't know if there's anything else to say. Let's just see if it can work with that. All right. I do want to add that to some sort of documents field. Yeah, so WIT keywords can't be parameter names. At least this was a limitation that has survived in my agents MD file for quite some time. Maybe it's fixed now. I know soon it won't be relevant. The static moonbit wrapper, I think, is the cause of this limitation.
Probably. On the latest main branch, it's no longer the state, but I'm not recommending to switching to that right now.
Yes. I chose not to. I thought about it last night. Should I pull it? No, probably not. This one is known to work. This version is known to work. Consequences of living on the cutting edge of Golem development. The last official release is 1.4.2, right?
Yes.
Yeah. Okay, so it's doing a bunch of stuff here. Okay, so what URL did it call? HTTP bin. Okay.
Yeah, that's just a test URL.
All right.
Yeah, always calling that.
That's great. So let's modify this. Maybe we've got fetch URL here. Is that what it's called? Yeah, fetch URL. It takes the URL as a string. It fetches it, gets the body, and then just returns it. So maybe what I'll do now is I wanted to store this in documents, but now I'm thinking really we should probably store a summary of that in documents. Or maybe what we should do is store the raw document inside documents, and that way we can later choose to summarize it if we want. Or maybe we need some sort of new command.
When you say documents, you mean that one sub agent for each of those documents, or what does it mean?
No, initially I was just thinking we would have like a private array here to store all the documents. Right? Does that make sense? I think it makes sense.
Yeah, we could do that.
So let's do that. Add a private documents array to chat agent and ensure that every fetched URL content is added there so we don't lose it. So every time you call fetch, it's not only going to give you back the body, but it's going to store that in documents.
But then in the next step, we could demonstrate that we can scale this by moving every document to its own child agent.
Well, what we can do potentially, right, is we can actually have one of these agents or maybe a different agent. Right? This is chat agent is actually becoming more like research agent at this point. But what we can have it do is spin off a bunch of child agents. And each one of those is doing something. And then maybe they summarize it, and then we get back a summary of the research. Okay. Right, the model doesn't know about documents. So that's expected. So it's a array of URL and body, which makes sense. We might want to canonicalize the URL at some point. The body is just whatever response.txt gives us, which is probably going to be raw HTML. And then fetch URL, it is pushing that tuple onto the documents array. And then obviously we're not exposing that information to this agent. So I'm thinking about just to sort of prove this is working and be more consistent, do we want to add another tool that allows the agent to look at its documents or to include them as context, right? Well, we
Yeah,
don't
we could do that, or we could add a tool to get a summary of a page, and that could reuse this somehow. I don't know. Yeah, I don't really have a vision of where we are going with this.
Yes. How about this? Yeah, I don't know yet. I know we're working our way to, like, I feel like we should have some utility in what we've made before we go to parallelize. In other words, make this somewhat useful by itself. And then when it's useful by itself, we'll start thinking about, oh, maybe we want to parallelize the fetching. And there's additional steps here, which we could potentially undertake, which would be, we have this HTML document. Maybe we want to extract links from it. And maybe in some cases, we want to follow them. So we can actually rip a whole section of a website. Obviously, that's much more complicated. If we're going to start crawling, then we need all sorts of mechanisms to ensure termination and to deal with loops and, different URLs that actually have the same content, etc. So let's just start off, before we think about parallelizing it and being able to do research across lots of URLs simultaneously. We will add, maybe, I'm thinking we have a couple tools, one that lets us list documents and one that lets us look at the content of a document. Does that make sense? I know list documents will show us summaries. Okay, how about that? So when you list documents, you get the URLs and you get summaries. So make the following changes. When a document is fetched, use generate text, fresh context, to generate a summary of the document and push that onto the array as well. So now every time we push new information onto our documents array, it's going to contain a summary of what's in there. Add a new tool to list documents, which returns a list of tuples, URL plus summary. Add a new tool to get the full content of a document identified by URL. Does that make sense? Am I missing anything?
I don't know yet. Let's see what happens.
Add the tools as agent methods, but also expose them to query as tools like the pattern we have already. So that way, not only will we be able to call these tools like list documents and whatnot just for testing and just programmatically, but also if we just call generic query, it's also going to be able to access this information if it needs to. So that means one of the things that we'll be doing is this documents array, which is inside chat agent, is going to grow horizontally. It's going to get a summary field, which is a string. So you can see here's the tool definition for list documents and a tool definition for get documents. Here inside, we've got an array of records where this new field called summary of type string has been added. And then we've got get document and list documents, and they just look relatively straightforward here. Okay, so let's just go ahead and test this, make sure that it's working as specified. So I'll get Alice. And then what was that test URL?
That's just returning a JSON. Let's try it with the Golem website or something. That's more interesting.
Oh, yes. So let's do agent fetch URL for HTTPS golem.cloud. No, learn.golem.cloud. Or maybe golem.cloud. Maybe start here. So it's got to get the content of golem.cloud.
Mhm.
You know, we don't know for a fact. Oh, it did. It actually worked. It must be megabytes in size. All right. Well,
Why is that so big? We shouldn't have a web page that is so big.
it's monstrously huge. So this just leads me to change a few things, right? So I didn't anticipate this being megabytes, but it is very large. So here's what we can do. I think that when fetch URL returns, it should not return the body. It should return the summary, because who knows how big it is. And the summary is more valuable anyway. And then also right now, we are, well, actually the agent has access to the summary. So let me just modify that. We'll say when fetch URL returns, it should return the summary and not the body, because the body could potentially be huge. And then we already have the other method that we can call if we want to get back the full body. It's called get document. So while it's thinking, let me just do dot list documents. Oh, I don't like the formatting here, but I guess it's just JSON. So we have two documents. We have its test, that is to say open codes test. And then we have our test, which was Golem Cloud. And that looks like it's doing its job. Okay, so now our agent can fetch URLs, store them in memory. It can also, we've exposed, oh, I suppose I haven't tested that, but I would be shocked if it weren't implemented. Just ensuring that we're exposing all of these tools. List documents, yes, we're exposing list documents and get document to our language model. So what that means is if we ask our language model to fetch a URL, then it can probably do that. Let me just verify that. Don't expect there to be any difficulties. It will take a while now and then give me back the summary, in theory. Okay. And then now let me call query and say, what documents do you have access to? Yes, that's correct. Let me, well, actually, this would be cheating. I was going to say, like, what is Golem? But that would be cheating because this information will be stored in the message history. What I'm thinking here is that we should always be telling the language model what documents it has access to. And we don't necessarily want that to clutter the conversation history. But what we could do there is inside query for providing history, we can just append, or rather, make a new array that contains all the old history plus the list of the documents. And that way, the agent is always aware of all the documents it has access to. Let me go ahead and make that change, and we'll test it, and then we'll be good to work on parallelization. All right, so okay, so what we want to do is just every single time you call query, we're going to include information on which documents the agent has access to, which it has fetched and has summarized and has stored in memory. And it's chosen to do this as an initial message, which I don't love for architectural reasons.
And it's also including the summaries. I think we don't need that because it can query the summary by
well, I think it's true, but how would it know to look at a given URL? The summary will give it hints as to which URL to look into.
It's going to be huge if we have a lot of documents. Just that's my point.
Yes, that's right. But also when we expand this to be the parallel case, right, and we're doing lots of things in parallel, we can have a different type of agent that's doing the orchestration, and it is like choosing exactly what it wants to do. Okay, so let's test this, make sure that it accords with our expectations. I'm going to fetch Golem Cloud. Actually, first I'll just list. This should only be the test document because I'm pretty sure, yes, it blew it away. Blew everything away. So I'm going to add Golem Cloud to its documents. We know this will take a while. And now the real test of this will be, we'll ask, what is Golem Cloud? What is Golem? Well, that's just literally repeating that to me, which is fine. I guess I could ask something that's on the homepage, but not in the summary, to see if I could get it to access
it's
that
not
tool.
exactly the same, just very similar, but it's not the same.
Oh, you're right. Yeah, they made some small changes. Copy editing, refinements.
How do we know if it read it from our document store and not just from its own whatever?
And console logging. We'll just log all our tools. That way we can see it when it happens. That way we can be extremely paranoid and make sure it's doing its job. Okay, so now while it's working on this, we can think about how we want to parallelize this. And lacking access to a search engine, the only way I can think to parallelize this is to look for, basically to crawl the website. Can you think of another way?
What I would do is that I would create a new agent called website or whatever.
Yeah.
That has a URL parameter that identifies it.
Yes.
And then just a parameterless fetch on it that does the same thing and stores the summary and the contents inside that agent. And that's the first step to move this or to scale this horizontally among a lot of separate agents and not storing everything in our main agent.
Do we need that? Because one of these agents can just make new agents of the same type.
Oh, I feel like that's a cleaner design, but
okay. So we would have a fetch agent, I guess we would call it. Let me just do a little testing here because we added all that log information. So we get Alice, we fetch the URL, we can see fetch URL, this being called. And then we ask the agent, what is Golem? So that's interesting. It didn't call any tools. And this kind of makes sense. And the reason is this summary is appended to the message history. So it doesn't need to. We would have to ask something that is not inside the summary, but which would be in the document, and see if we could like carrot the agent into looking at that. But because that's not going to serve the main purpose of our agent here, I'm not going to bother with that. So we want to create a second agent called, second type of agent called a fetch agent, which will, whose constructor parameter is a URL and whose run method will fetch the URL, summarize it, and store both the document content as well as the summary inside the instance. So basically, we're just factoring that part out. We expect run to be called as often as necessary to refresh the content. So we'll add the second agent type. Once we have this, then we'll now be able to spin up in parallel a bunch of agents, all fetching different URLs, and each one independently summarizing them. And then, of course, we can refresh them at different intervals if we want. So the real problem I have, though, is what I mentioned before, and that is we don't have a web search API to call, and that would be ideal. So we can try to add, maybe the problem is all these are going to require API keys, and we're going to have to pay money probably to use them. So what we really want is a web search API that we could use for free with a free API key or something like that. And that way we could search for content on the web and we would get back a bunch of URLs, and then we would parallelize the task of fetching and summarizing all these URLs into sub-agents. And then our main orchestrator agent would be able to use those summaries in an intelligent fashion. Any ideas?
Oh, I don't know. Let's first try to use these new agents from our original one. So instead of having a document store just always use agent RPC to reach out for the data. And we still need to store the list of URLs, but nothing else. So we need a catalog of URLs that we know that we have agents for, but we don't need to store the contents in the main chat agent, or what was it saying?
Okay. So is this enough? You want to store the URLs, right? So we actually just need a array of URLs, right? That's enough.
Yeah, I think so.
Actually, we didn't even need it to store that, right? Actually, to implement our current functionality, we do. So I'll just have it make this change. I was just thinking that, it can spin up new fetch agents whenever it wants, so we can treat it as having already fetched everything. But if we still want to do our get documents, right? Our get documents relies on enumerating all of the things that
the
user has called fetch for. So just to emulate our current functionality, we'll need that array of URLs.
Yeah, that's the only reason why we need it.
Okay, so now we'll have it all farmed out to subagents. Maybe we can sort of demonstrate that. Golem agent list, we can see right now there's a single agent, which is resulting from the last testing round that OpenCode did with fetch agent. It's good that it tested it because we haven't tested it. Component revision here is at 10, and that's because there's a single component that contains a single TypeScript component that contains both of these agent types. All right, it is proceeded to testing. So I see a chat agent here, and then fetch subagent. Let's just take a look at the code to make sure that it makes sense. Here's our fetch agent. Here's the URL. It initializes stuff. And here, this run method, which could also be termed summary, fetches the URL, summarizes the content, refreshes the stored body in summary.
Yep.
This returns the summary, that returns the body. So it looks good. And then this one, when it's getting a document, it just delegates to that fetch agent, right? It's talking to a remote fetch agent, different subagent, using agent-to-agent communication. And here, list documents. It is also communicating. And this I feel as an, well, no, as an optimization.
Oh, it's because it returns the summary. That's because it's doing it.
Yeah, as an optimization, we could pull that here, but this is fine. Okay, so now we're ready to parallelize potentially without yet solving the problem of where do we get these URLs. We basically need a search engine API in order to get the URLs, because what we want to be able to do, I think, is give our agent a topic and have it research that topic. And to do that, we are going to have to use web search at some point, and we'll get back summaries and URLs, and then we can just directly add those. And later we can decide which ones we want to crawl. Right now, however, we could just assume that we're given a bunch of URLs, or how about this? what we do is we add to fetch agent a way to extract all URLs inside the content.
Yeah, that's what I wanted to recommend. I'm sure that Cloud can write you a very nice HTML parser in a second.
We can tell it to use an npm package.
Yeah, let's do that instead.
If we knew TypeScript, then we would know which package to use, but I don't. So add another public method to fetch agent that scans through the body of the document. Or actually, what's it called? It's not called. It's actually called, yeah, it's called body. URL, extracting all URLs and returning an array of these URLs. If there is a npm package to do this or to assist in doing it, actually, we could just call, we can actually, no, I don't know if that's going to work on Node.js.
I hope that
Should we try this?
Yeah, we can try. I just have to mention then that there is ongoing branch that is not available yet to try, that gives a much better Node.js compatibility to Golem than the version that you are using. So if that npm package that it chooses will not work, that's not that surprising.
Oh, here's what we want. Extract URLs, plain text regex based. Oh no.
That's probably working.
It's decided to pull in Node HTML parser.
It can still, well, we will see.
We will see. This could go horribly wrong.
So the next official release will have a very good Node.js compatibility, but that's not in this version yet.
Yes, it's a reduced Node.js environment in 1.4 in this main version. 1.5 will have, in theory, almost complete Node.js support. All right, so what's it doing? Did it successfully add? Okay, it did. At what level, though? That it's working. Look at that. I guess we won't know until we try it ourselves. Oh, pure JS HTML parser. Perfect. No native dependencies. Works in Golem's quick.js runtime.
Oh.
Fantastic.
Yeah, actually, the root agent file in that Golem new generated is containing references to what APIs are available and what not, so it should be able to figure out.
Perfect. Okay, so the results include relative paths and non-HTTP schemes from HTML anchor hrefs as is. Resolving absolute URLs would require knowing the base URL, which is available at this URL if needed in the future. Okay, well, I think it's a good idea to change that because the knowledge of the base URL is consolidated in fetch agent. So when you call that, it should return absolute URLs. But let me just go ahead and try this. We'll grab our Alice agent. We will fetch that URL. And now we're going to actually get back a fetch agent this time. So we'll just say let Golem Cloud is equal to fetch agent.get HTTPS. I really want to canonicalize these URLs. Get summary. There's the summary. And get, what do they call them?
I don't know.
extract URLs. Well, look, there's our Discord link. If anyone wants to join us on Discord,
Even has your telephone
there
number.
you go. Yes, well, that's not mine, fortunately. It's company telephone number. You're free to spam this one all you want. Okay, so this looks good. What I would say, though, is let's go ahead and change extract URLs to turn absolute URLs by taking relative URLs and appending the base URL. Also, it could be a good idea to, I won't do this yet because it requires us to update the call sites of fetch agent. So I think this is enough. I'm going to have it fix this problem, and then we will be ready to parallelize. So we have now a way to rip a single page and return child pages, more or less. And now I think we have enough functionality to fairly easily build a parallel web crawler. And we need to think a bit about the conditions in which we want it to recurse. Obviously, we don't want it to traverse the same information more than once. Right, so
I think that is protected by having one associated agent for each URL. So if you call run twice, the second run shouldn't do anything. We should add the check into it. If it's already computed, then don't run it again.
Sounds good. So I'll change run so that it will never recompute summary or body. Add a separate refresh that does refetching and re-summarizing. So this one here will be you call it once and you're done. If you call it again, it's going to have no effect. If you want to refresh, then you have to explicitly call refresh. And I don't think we can have async constructors, can we? Otherwise, we could just initialize everything in a constructor and just expose refresh.
That's above my TypeScript knowledge.
We need actually
we are going
someone who knows what they're doing to join us on these TypeScript live streams.
That's why we have the coding agent. Yeah. But we need some kind of recursion depth limiter. Otherwise, we are just going to spawn infinite number of agents.
That's right. That's right. So, and it seems to me like we still need to, not just recursion, I guess, because I just don't want it to have to call run on things that's already called. Because even if it's a no-op, it's still agent-to-agent communication network overhead. So it seems to me like we still want to sort of maintain, even if it's just in memory temporarily, this sort of visited. These are all the things I visited so far, and I don't want to call, fetch agent. I don't want to make a new fetch agent for them and call that.
Oh, but that means that you want to centralize this crawler.
How are you thinking of doing it? You don't need to centralize.
I was thinking of something that just spreads out, like you go run and that with some depth parameter, and if it's bigger than 0, then it just spawns a tree of these things.
Okay.
There is no particular reason. It's just fun to see it's happening.
So would you do yes? Would you do that inside chat agent?
I was thinking of these what was it called, the fetch agents themselves doing this, but I don't know. There are many ways to do this.
Yeah. So this would be, we call run. Let's just think about it here, right? We call run, And in here, we get the body. We can potentially from here, we can extract the links.
And then we can use a trigger feature that we haven't mentioned yet. So we can do agent-to-agent communication without waiting for the results. So we can just spawn these sub fetches here, and we don't have to wait for them.
Makes sense, but then how are we going to collect the results?
I don't know.
Because we really want to be able to say, you know, in some sense, what we're moving towards is
we could add the spawned child agents to the chat agent because it has a centralized list of URLs, for example.
So it has a list of URLs here, and in that list of URLs, it has the associated agent.
The URL itself is the agent, so you don't need to store any association.
Maybe it would be better to just rely on effects concurrency capabilities to spawn them all off, collect all the results, and then we just need to make sure that we're not calling ourselves recursively. Right? We never want to call ourselves recursively. And also,
for that, you have to propagate this history because otherwise you can transitively call yourself recursively.
Right. So at every single, I'm trying to think if this is sufficient. When we recurse, we specify not just everything we've seen before, but everything we're going to see as a result of this parallel pass. No, that's not enough. Because different sub-branches of that tree will not know about each other.
Yeah.
Yeah, this is an interesting problem.
We could broadcast, so every run could broadcast its own URL to this central registry of known documents.
This just makes me want to. This just makes me want to stick it all here in chat agent.
We can do that as well.
Right, because then we can have like consolidated logic here, and the fetch agents are not going to be recursive. They're not going to be doing anything funny. The logic will be consolidated. We can use as much concurrency as we want inside the orchestrator agent, if you will, and it can collect all the results in some sort of sane, sensible fashion.
I think the difference is that then this orchestrator, it's a difficult word. Anyway, so this agent will not be able to respond to other things while it's doing this scrolling, because it needs to be a single invocation that awaits all these promises.
Let's have another orchestrator, right? We'll have another agent here. We'll call it fetch all.
Mm-hmm. Oh, and that will be responsible for one single crawling session. That's good.
Okay, so we have add a new agent type called fetch site, which will take a URL and also expose a run method. But this run method will take certain parameters. Chiefly, what I'm thinking about here is depth. We never want to visit the same URL more than once. But also, we don't want to go more than a certain number of levels deep. And it will collect, it will run will have it has a set of URLs, which is initially just the seed URL, and then it creates a fetch agent for each, and using effect runs them all in parallel, building a new set of URLs for the next pass, running up to the specified number of passes. Does that seem correct? We start off with a first initial URL, and then in parallel, or concurrently, I should say, we go and we spin up all the fetch agents and we get them to compute their stuff. We collect all the results. Oh, but what's the in-memory structure we want here? The in-memory state of the fetch site agent will be an array of URL summary tuples, because given that URL, we can always get its content later. So I think that's enough. That allows us to retrieve more content if we need to. Does that seem sufficient? So right now we're just adding this new agent type, basically crawl a website up to a certain number of passes.
Yeah, sounds good to me.
And then we can later integrate this into the chat agent. So the chat agent, I think, would change in the following way. There's really no reason to have the chat agent have this list of have this. No, I can still have URLs, but these can be sites. Right? This is basically sites. And what we can do is change fetch URL to something like add site. And so we add the Golem Cloud website, we add this other site, we add this other site. So we're not talking about documents here, we're talking about sites. And then we still need a tool to pull back the content for a URL, but we already have that. As far as I know, this is not going to change. Get document will, well, actually, no, it's not going to do that. We'll just change this to be get document. We'll change that to be get URL, and it will be able to directly use fetch agent to get back any body of any URL, even if we've not scanned it before. I think that will be the handiest thing, the handiest way we can implement that. Okay, what else? So we change get document to be get URL. Let me just start preparing these notes. Change get document to be get URL. It won't check URLs. Actually, let me describe all of these changes. Our first change should be change URLs to be sites, with the understanding that it is still a list of URLs, but each URL represents a site that has been crawled by the agent and whose content is or will soon be available. Okay, so we've got sites, and then fetch URL changes to add, or no, crawl site. It still takes a URL, but then uses fetch site agent to fetch the whole site up to the specified number of iterations. Okay, so that's changed to crawl site, or maybe I'll just call this add site. What else? List documents. No, fetch URL. Yeah, list documents. List documents changes to list sites, and the corresponding prompt to the model is updated so that it understands it has comprehensive summaries of the specified URLs and can retrieve the content of any page on that site. And then get document. It's changed to get URL, and it uses fetch agent to get the body, body of the specified URL, whether or not it has been previously scanned. This will add us an ability to sort of memoize the results of fetching different URLs, because all this stuff is durable, stateful. I think that's all. But while it's working on these changes, let's go ahead and review what it did for fetch site. The fetch site agent, it has a seed URL. What? Oh. Okay, yes, that's right. It's maintaining pages of URL and summary. I don't like that. Look at that. It's not storing the body anywhere. Does it need to? No, not
It's
really.
more efficient, more memory efficient this way.
Yeah, because the body's already stored in the corresponding fetch agent.
Yeah, it only needs the body until it accepts the URLs for the next level of pages.
Okay, so it is, oh my, it decided to use promise and not effect. Well, it's using effect here. And then it's using promise all here. It didn't exactly...
Because our agent to agent calls are not effects but promises.
Yeah,
but it could wrap it one by one to be an effect.
It could and should. This, I think, is where having an effect specific integration could go a long way, because then everything can stay in effect. You never have to see a promise. Okay, so we have our loop here going through all these different passes. Each pass is done in parallel. We're keeping track of all of the stuff we have that's been previously visited. Which is a set and not an array, which is good. Okay, so, overall, this could have bugs in it, but overall, it seems like it's correct. Would you agree?
Yeah.
This is what I would expect at a high level. Okay, so now it should be busy refactoring this. Let's just make sure it's refactoring it correctly. So we have a list of sites. All these are URLs. And then this is changed to add site. And it's using fetch site agent to get that and run it with a specified number of passes. And
what is passes? Is it the recursion count?
It's basically depth, yes.
Or the number of pages? Or...
It's recursion.
Okay.
It's just done in a loop, so I didn't call it recursion.
Oh, yeah.
And let's see. I don't know why it's bothering to do that, but I guess that's fine. So just make sure that it's not re-adding the same site. And then list sites, it's returning the URL and the summary of all those. And then get URL, it doesn't have any check here. It's just going to directly call this. That's correct. That's what I want. So I think all of this is correct.
Looks good.
So let's test it. So we add we get our agent Alice, and then we do agent add site HTTPS golem.cloud, and we'll set our recursion limit at 6. Oh, we should have added more logging. Not that that would help us here, right? Because we're doing agent to agent.
Yeah, it added logging to the child agents, but we don't have
see them.
any way to see these.
That would be great if at some future version we could. I don't know how we would support that, but it'd be great if you could see the log output from sub agents.
Yeah. There is a nice pattern that we can quickly implement that I did in my Golem applications before, that you can actually create your own log aggregator agent. It's a few lines.
Okay. Oh, right. Yeah. Log aggregator.
And you can just change the console logs to be actual calls, the agent to agent triggered calls to that log agent. So you can bring the whole problem of aggregating all your agent's logs into your applications domain. It's very simple.
Very nice. I am going to say this is probably not going to work.
I think it's just slow.
Well, actually, let me share my other secret hidden Golem window.
Oh no.
And what I guess is happening is that might be too small to see. Let me just change.
Yeah. Well,
okay.
It shouldn't
so
cause an infinite
protocol error.
Infinite loop, but whatever.
No, I think what's happening, possibly is that we're ripping these pages so fast from what would be Webflow, because the Golem Cloud site is hosted on Webflow, that it's triggering some sort of error, right? Handshake failure in TLS. It sounds to me like,
if it's continuously getting the same error, then it's already printing that it's transferring uplog entries to the secondary layer, because that means that there are so many of these errors logged into the agent's uplog that it had to
we
compress
probably
some and
need
move out.
error handling, which we don't have time for. But let me just go ahead and summarize what we've done here and what remains to be done. First, I'll share my screen again. Yeah, so Golem automatically retries errors, which in this case probably just leads to cascading errors, because if Webflow is denying us accessing these URLs because we're doing it too frequently from the same IP address, then retrying, of course, is just going to increase the problem. So we need here, unfortunately, we need some error handling. We probably need to catch failures and handle them. And we probably need to space things out. If we're going too fast, we probably need to space things out, slow things down in order to be able to successfully rip a website. I don't know how many URLs are being generated here. That would be another interesting thing to add. What I will do is I'm just going to kill the REPL, that is. Can I kill the REPL?
Yeah, I hope so. You can kill the whole server actually and start from a clean state, because because it's now full of these error logs, which
All right, I
shouldn't cause
killed
any
the whole
problems, but
server.
it's better to
And then let me
use
just
a clean
do,
state for the demo.
oh, it is busy, busy, busy. I can't kill it. It's coming back. It's coming back to life.
It's durable.
It's Golem. Yes. So I need to, yeah, it's coming back to life. It's not happy. So I don't want to actually, I don't want to blow, I want to run Golem agent list. Maybe I can do that actually, even though it's bringing stuff back to life. No, it's like, it's in startup mode. I think it's trying to restore all of these agents that we're running. Who knows how many thousands of agents we have running. Yeah, it can't even
Yeah.
get a hold of localhost because it's so busy. So I just wanted to see how many agents and start diagnosing things, but it looks like we can't do that quickly today. So I'm not even going to try. So where did we end? Well, what we've done now is create a monster that cannot be stopped or killed. But I think architecturally it's correct, even though we need more work around error handling. What we're doing here is we have one agent which can fetch a whole site. And how it does that is by spinning up lots of subagents, which are all going to be persistent. We might not want that. So actually it occurs to me, perhaps a better design would be to make this an ephemeral agent. Fetch agent, potentially. If the main thing we want is a summary, we can always go back and fetch specific URLs because the agent might decide I want that URL by looking at the summary. So the best thing to do here might be to make this agent type ephemeral, and that way we don't have to worry about that. But anyway, this one spins up a whole army of these things in parallel. It could be 10, it could be 100, it could be 1,000. It depends on how many unique URLs. I hope it's doing unique. That's something I didn't check. One visited. Yes, it should be.
Yeah. I think there are a couple of things here that are going to be better when we are ready with the stable
1.5.
version of this Golem.
Yes.
For example, we could include that log aggregator thing in the SDK itself, so you can just enable it very easily.
That would be nice.
Also, yeah, and also we had plans to improve the HTTP backend that this whole thing is built on.
Yes.
So maybe there is a bug there that had this repeated error not going away, or just overloading, opening too many sockets, whatever. I don't know, but we have to investigate this.
And yeah, it has to be investigated. The other thing is, obviously, the local version of Golem uses SQLite. And so right now we might be overwhelming the ability of, like, it's not a, it is a production database, SQLite, but it's not designed for massive scalability. We might be spinning up, without more logging here, we might be spinning up tens of thousands of agents and quickly overwhelm the ability of SQLite to keep up with all of that. So there's a lot of things I think we need to poke around here and see if we can get this example to work. But I think architecturally it's correct to have one agent fetch a whole site. I think it's correct to do all this stuff in parallel, but also to limit depth. Also keep track. This gives us a consolidated single place to keep track of this set of URLs that we've already visited, which is what we want to do, I think. And then back here in the main agent, the other thing we would probably want to do that I did not do is trigger add site. So we didn't talk about trigger. Daniel mentioned trigger before, but basically every single agent method you can invoke in 3 different ways. The primary way, which is just the way that you see in, where is add site? It's just like this: await fetch agent get URL run passes. Right, so that's the primary way. But you can also call on this dot trigger, and that will kick it off in the background, and it's not going to wait for its response. Probably we want to do that here because we don't want this method to block based on crawling the whole site. Crawling the whole site would probably take minutes. Crawling and doing summaries on all these different pages would take minutes. So we don't want to block that. We would want to trigger this and then just return like unit here. Basically, trigger always returns unit. The other thing we could do here is call schedule, which we don't need in this particular example. But we can call methods normally, but then Golem adds, the TypeScript SDK adds two other ways to call things. One is by triggering them, which is running in the background. And then the other one is by scheduling them to run at a certain time. So actually we do right here. It's triggered here.
Yes, it's there.
Yeah, and schedule here. And I don't have the LSP installed, so I'm not getting autocomplete. I still have yet to set that up. But anyway, we would trigger that here. And then that way, when the agent is actually looking for content, it can go look for content and it's going to get what it can. That's the way we would want to structure this, is allow the agent to get what it can. If there is some stuff crawling in the background, then we would want to let that continue and not interfere or block the main agent here. And other than that, I think this is a reasonably good example. I think maybe what we should do next time for one of these demos is come into it with a web search API already preloaded. That way, if we wanted to do a proper research agent, then we would have an API key ready to go, an NPM library. I can research and find out what's the best library to use for web search. And that way we could build something more than just crawling. Crawling is great, but it's not a very realistic way to do more than just research a single site. All right, well, hopefully everyone has enjoyed this demo of using Effect AI on Golem. And as you can see, one big takeaway for me from this is just based on the fact that we are having to go between effect and promise, we definitely need to do an effect integration to make this really nice. And it could even be like, instead of calling agent here, you call it effect agent or whatever. And it would just allow all of your agent methods to return effects. And every time you did agent to agent, you would get back an effect. And so you could just chain and seamlessly use everything. I think that would be really fantastic to have a proper integration between Golem and effect that doesn't require we constantly move back and forth between promises. So I hope you've enjoyed this demo. I hope you have also seen how powerful Golem is, how easy it is to build distributed systems that are extremely reliable, to build agents that never forget and never duplicate actions, and also just how agent-friendly Golem itself is, in the sense that I haven't actually edited a single line of code. I've just had open code do all of this work, and it almost never encountered a problem, and it quickly overcame any problems it ran into. So Golem it brings the power of building highly complex, highly reliable, stateful distributed systems to coding agents. Now you can vibe code your way to big, very impressive distributed systems that can run reliably and scale to, hundreds of thousands of agents, et cetera, on a real production deployment of Golem, not the local one that's just using SQLite. So please join our Discord, where you can find Golem contributors hanging out on. And you can also ask questions. You can see what other people are working on. And if you want, stay tuned to our blog for release of the impending 1.5, which is going to bring some of the functionality you've seen today to a released and supported version. Some of the stuff you're seeing here is pre-release, like mounting the agent at a given URL and stuff. That's all pre-release. You can't get that from the official release. If you want that, you're going to have to build Golem from scratch. But it is coming out actually in a matter of weeks. So just subscribe to our blog or hop onto the Discord, and we'll let you know as this stuff comes out. Hope you have enjoyed this demo. Thank you, Daniel, for helping me get through some of these issues, architectural issues and Golem issues. And then we'll see everyone at the next live stream.
Bye.